elasticity. And at the end of today's lesson, students should be able to define elasticity. 2. State and explain the terms used in elasticity. 3. State Hooke's law. And lastly, solve some calculations on Hooke's law. What is elasticity? A substance is said to be elastic if it returns to its original shape and size after being deformed, that is, stretched or compressed by an applied force. And when we mean deformed, deformation occurs when a wire is stretched or compressed. And deformation is elastic if the wire returns to its original position, while it is plastic if it does not return to its original position. The extent of deformation depends on 1. The magnitude of the applied force, and 2. The nature of the substance. When a thin wire or spring is subjected to varying magnitude of load or force, the string increases in length, which is known as extension. Our next line of discussion is the term used in elasticity. The following are the terms used in elasticity. 1. Elastic limit. Elastic limit simply means the maximum stress or force per unit area within a solid material that can arise before the onset of permanent deformation. It is the point on a stretch or string or load or tension graph beyond which Hooke's law is no longer obeyed. 2. Yield point. A yield point is the stress at which a material begins to deform plastically. Before the yield point, the material will deform elastically and return to its original shape when the applied stress is removed. Or you can also refer yield point as the point reached when a stretched wire does not return to its original position. 3. Maximum load. This occurs when a load is added to a wire that cannot stand any further increase. And lastly, break point. This is the point at which the wire breaks away from the original, having been stretched beyond the yield point, where it cannot stand any further stretching. A good example of this is illustrated in the diagram you can see on your screen, where you have your break point, your elastic limit, your maximum load, and your yield point. And this now leads to our next line of discussion, which is Hooke's law. Hooke's law states that the force applied to an elastic material, that is a spring, is directly proportional to the load or applied force, provided the elastic limit is not exceeded. With this, mathematically, we have F to be proportional to E. That is, force is proportional to extension. So by taking off the proportionality sign, we have F is equal to KE, where K is the constant of the spring or wire, which is known as the stiffness or elastic constant. If force is measured in Newton and extension is measured in meter, then we have K, which is the force constant, to be equal to force divided by extension. So we have our force constant to be measured in Newton per meter. The diagram you can observe on your screen is the graph of Hooke's law where E is the elastic limit, Y is the yield point, M is the maximum load, and B is the breaking point. Now let's take a look at a good example on Hooke's law. A spring of material length 3 meter is extended by 0.01 meter by a force of 4 Newton. What will be the length when the applied force is 12 Newton? From Hooke's law, we have our force to be equal to force constant times extension, where force is given as 4 Newton and extension is given as 0.01 meter. By substituting your force and extension into this, we have 4 is equal to K times 0.01. By making K the subject of formula, we have 4 divided by 0.01, and when this is divided, we have it to be given as 400 Newton per meter. So the question further said that what will be the length when the applied force is 12 Newton? So we have our applied force to be given as 12, but the extension, which is the length, is not known. So we recollect the formula, which is F is equal to KE, and we end up substituting the value of our force constant, which is 400 Newton per meter, and force, which is 12 Newton, into the equation, and we also make E the subject of formula. So at the end of the day, we have it to be given as 12 divided by 400, and which is now given as 0.03 meter. Now the new length after applying a force of 12 Newton is now 3.0 meter. Example 2. An elastic wire extends by 1.0 centimeter when a load of 20 grams hangs from it. What additional force will be required to cause a further extension of 2.0 centimeter? From the question, we have our mass to be given as 20 grams, and in order for us to convert it to Newton, all we need to do is to convert our mass to kilogram and also multiply it by 10, which is gravitational force. And when that is done, our force is now given as 0.2 Newton. And our extension from the question is given as 2.0 centimeter. So we'll collect Hooke's law, where Hooke's law is equal to force constant times extension, which is F equals KE. And we substitute the value of our force and our extension into the equation. Then we now have 0.2 Newton is equal to K times 0.01 meter. By simplification, thereby making K the subject of formula, and dividing 0.2 Newton by 0.01 meter, then our force constant will be given as 20 Newton per meter. But from the question, we are asked to look for the additional load. So based on this, we are going to make M to be the additional load required to extend the wire by a further 2 centimeter or 0.02 meter. So from this part, the total extension is now given as 3 centimeter, and when we convert it to meter, it is now given as 0.03 meter. Please note, we are looking for additional force. So the additional force that will be added to the initial force, which is 0.02. So we call that M. So which means our force is now given as 0.02 plus M times 10. So we now have our force to be given as 10 meter plus 0.2 Newton. By substituting the value of force and the force constant that is known into the equation, we end up having it as 10M plus 0.2 is equal to 20 times 0.03. By collecting like term, we end up having 10m equals 0.6 minus 0.2. 0.6 minus 0.2 gives us 0.4. Divide both sides by 10, we end up having our final answer to be given as 0.04 kilogram or 40 grams. Students, we've come to the end of today's class. In today's lesson, we have been able to define elasticity. We listed and explained in details the terms used in elasticity. We also stated Hooke's law, and lastly, we did some calculations on Hooke's law. Now, students, the question you can see on your screen is meant for you to solve. Kindly solve this and send to the school email. Thank you for being part of this class. Till I come your way again, keep learning, stay safe.